Hello. In this video, we're going to look at exam 4 review. We're on question 1, example I in that. So we're going to find the integral of 7x plus 2 all over 14x squared plus 8x all to the 4th power dx. Now notice that in the denominator here, we have something to the 4th power. And when you have something like this, this begs for the u substitution. So for the u substitution, we're going to let u here equal whatever's in parentheses. In this case, 14x squared plus 8x. Now, we want to go ahead and find the derivative here, du. The derivative of 14x squared plus 8x. Well, that's going to give us 28x plus 8 with a dx. Now, notice what we've done. We have 14x squared plus 8x. That's already right there. Wonderful. So that's our u. That'll be u to the 4th power in the denominator. But up here, 7x plus 2 is not the same thing as 28x plus 8. Notice that if I factor out a common factor there, the common factor would be 4. So if I factor out the 4, that gives me du is equal to 4 times 7x plus 2 dx. Now, the nice thing about this is that, well, frankly, I can go ahead and get rid of the 4 and move it over here because I need the 7x plus 2. I don't need the 4. So I divide by 4, or aka multiply by 1/4 on both sides. That means that 1/4 du is equal to 7x plus 2 dx. So the 7x plus 2 times the dx is this entire thing, which is 1/4 du. So I can go ahead and start finding the antiderivative. Now, the antiderivative then is the integral of 7x plus 2 times dx. Well, that's 1/4 du. So I'm going to put the 1/4 and the du here. And this is u to the 4th power in the denominator, but I'm going to go ahead and move it to the numerator as a u to the -4 power. Oops, sorry. There we go. So in purple, the stuff in purple is the stuff that did not change, and blue and green is the stuff that did change here. So now we just find the antiderivative here. To do that, well, the u to the -4 becomes u to the -3. And so the 1/4 out in front is going to be multiplied by -1/3, the reciprocal of the -3. Plus a constant. Wonderful. So this is going to equal -1/3 times positive 1/4 is -1/12. And instead of the u, we're going to replace it with the entire 14x squared plus 8x to the -3 power plus c. And I'm more than happy for you to just leave it like that. You can, if you want, make that -1/12 times 14x squared plus 8x to the 3rd power in the denominator, plus a c out front. But there you go. Here is I. Next, let's look at j. For j here, this is the integral of z times the square root of 9z squared minus 5 dz. Now, this begs the u substitution as well. Anything underneath a radical like this that has more than one term really does want us to use u substitution. Now, notice that the z out in front is actually is the derivative of z squared, almost just a coefficient difference. So that's another reason why you would want to use u substitution. So I'm going to let u here equal the 9z squared minus 5. Now, the derivative of u, du, sorry, I'm going to use blue here. So du is equal to 18z, and that's it, with a dz at the end. Wonderful. So now if you notice, we have the dz, but this is just a z, not an 18z. So instead, what I have to do is I need to get rid of the 18 by multiplying by 1/18 to both sides. So it'd be 1/18 du is equal to z dz. So the z and the dz here is 1/18 du. And the 9z squared minus 5, that is just u. So this integral is going to become the integral of, instead of z dz, it's 1 over 18 du. So that's 1 over 18 with the du out here. And instead of 9z squared minus 5, that's u. And since it's the square root, I'm going to rewrite it as to the 1/2 power. So that'd be u to the 1/2 power. And there you go. And now just find the antiderivative. So we still have the 1 over 18 here. And then u to the, well, 1/2 plus 1, 1 plus 2 is 3. Keep the denominators 2. And then we take that coefficient, the exponent here, and multiply the coefficient by the reciprocal. And so that'd be 2/3 out front, plus a constant. Now the 2 divided by 18 is, the 2 and 18 share a common factor of 2. So 2 divided by 2 is 1. 18 divided by 2 is 9. So 1 times 1 is 1. Over 3 times 9 is 27. So that's 1 over 27. And instead of u, I'm going to replace it with 9z squared minus 5, and then raised to the 3/2 power plus c. And there you go. That is j. Now for, actually, now for k. K is the integral of 6x to the 5th e to the 9x to the 6th dx. Now notice that our exponent here is more than just some constant times a variable. So it's more of a function of x. It is a function of x before, but this is even more so. Beyond that, though, notice that x to the 6th, its derivative is an x to the 5th of some sort, right? So, and notice that there's an x to the 5th here. So that's going to tell me that I want to let u here equal the exponent 9x to the 6th power. So the derivative of u, du, is 54x to the 5th power dx. Now, notice that we have 6x to the 5th and not 54x to the 5th. So I can do this one of two ways. I can change this to by multiplying by 9 and then putting a 1 over 9 out in front. That's probably how you saw it in MyLab Math. But for me, I'm just going to go ahead and multiply by 1 over 9 on both sides here to get this to be a 6. It means that 1 over 9 du is equal to 6x to the 5th dx. Good. Now notice we have the 6x to the 5th dx. So we have 6x to the 5th dx. And we have the u up here as 9x to the 6th power. And that's right there. So that's u. So this integral is going to become the integral of 1 over 9 e to the u du. And then we just take the integral of this. And because it's 1 over 9 e to the u, that's just that it is its own antiderivative. So it's going to give me 1 over 9 e to the u plus c. But the u again is just 9x to the 6th. So this is equal to 1 over 9 e to the 9x to the 6th power plus c. And there you go. That is k. So here are I, j, and k. All right, I'm going to go ahead and end the video here, and I will continue in the next one. Have fun.